All right. Well, the first thing I want to do is continue the binary games, which we talked about before. I said I wanted to do one of these every week, and there's only 4 of them in this class, so that's doable as long as I don't forget. So let me put these in a browser that isn't in funny dark mode like this, so it'll look less ugly. Let's try Opera. I put my browser in dark mode after reading a study that all the blue light is actually bad for you, so I bothered to set most of my stuff in dark mode. Anyway, so we talked about nibbles last time, and let me just mention it again for people who don't remember or weren't here last time. So nibbles are the beginning of how to understand binary. Nibbles in a normal base 10 number, the number on the right is the number of ones, and this is the number of tens, and this is the number of hundreds. So that's 147. In base 2, you don't have ones, tens, and hundreds, you have 1, 2, and 4. So this number is 5. 1, 1, no 2s, and 1, 4. And good, that's my Windows machine booting up. So you can count to 7 with 3 bits. This is 1. 1, 0 means a 2 and no 0 and no 1s. This is a 2 and a 1. And 7 is a 4, a 2, and a 1. So 1, 1, 1 is 7 in base 2. And a nibble is half of a byte with 4 bits. You have 1s, 2s, 4s, and 8s. So that 4-bit object is called a nibble. And there are only 16 possible nibbles, and there they are. So 1, 1, 1 is 7, 1, 0, 0, 0 is 8, because it's no 1s, no 2s, no 4s, and 1, 8. And this is 9, a 1 plus 8, and this is 15, 1 plus 2 plus 4 plus 8, which is the largest nibble you can have. They only go from 0 to 15. There's only 16 of them. So that's nibbles. Now, for bytes, you have 8 bits in a byte, and so there is an easier way to do it, which is hexadecimal, but the most obvious way to do it is this way, and this is where people generally start, and it's where I'm going to start, is to just extend the same logic we had before. You have 1s, 2s, and 4s. You can count to 7, and you can count to 15 if you add another bit. So that's 4 bits with a nibble, 1s, 2s, 4s, and 8s. But a byte is now 1, 2s, 4s, 8s. This is 16, 32, 64, and 128. So this number, 1001, 1001, is 128 plus none of this, plus 16, plus 8, plus 1. So this is 153, is that number, those 8 bits. And this is one way to get what it is. This is the hardest way, but it is the simplest to understand. Every place to the left doubles the significance, and you just go from 128 to 1, adding up the numbers. So it can take a while, but you can answer questions here, and I'll just demonstrate a bit of one of these games. I don't have the Kahoot version of it set up. I'll probably have that next time. But for example, this one, let me make it a little smaller. There, I put a space in the middle, which is not normal, but just to make it easier to read. So what is this number in decimal? It's 3, right? You have a lot of zeros. You have a 2 and a 1. So it's 3. And that's also 3. There, how about this one? What's that in decimal? 37, right? Because this is 5, 1, 2, 4, and this is 8, 16, 32, so it's 32 plus 5. That's 37. How about that one? Okay. 77, very good. This is 8, 16, 30, that's 64, and this is 13. 8 plus 4 plus 1, so it's 64 plus 13, which is 77. And you might very well need to write down things down on a piece of paper to do this way. How about that one? Yes, and A core N has the right technique, which is what we're going to get next time, where the left nibble is the number of 16s and the right nibble is the number of 1s, which is fine. You can do it that way too. So what's this one? 16 and, 25, right? Yeah, because this is 16 and that is 9. So that's 25. Good. And one more I'll do. Well, how about this one? 22. Yep. This is 16 plus 6 for 22. Yep. Very good. All right. So anyway, when you get enough right, you'll get a flag, and you can turn this in Canvas and get points. And there's a couple of those where you practice with bytes. And next time, I'll talk about hexadecimal, which is closely related to these nibbles and such. And this is what we're really going to use. Hexadecimal is the most easy way to write down binary information so humans can digest it. So anyway, that's one project that you should be working on. And let me stop recording this one.